So in this video, I'm going to go over the performance final exam review. So first of all, it says plot the preimage rectangle QRST with the coordinates 2, 4, 4, 4, 4, -6, and 2, -6. So that's what these points are. So we have Q here at 2, R, and then S, and then T. Says dilate the image by a scale factor of 1/2. Label this image QRST prime. So what we're going to do is we're going to multiply. We're going to take our XY and we're going to multiply that by 1/2 X, 1/2 Y. So when we do that, we get 1, 2, 2, 2, 2, -3, and 1, -3. So that means, excuse me, our new points are Q, R, S, and T. Okay? Then it says translate the rectangle QRST 1 left and 2 units up. So to do this, we're going to take our X, Y, and we're going to go 2 left. That would be X. I'm sorry, 1 left, X minus 1, and Y plus 2 because we're going 2 up. Then we're going to apply that rule. So here we subtracted 1 from 1, we got 0. We added 2 to 2, that gave us that 4. Again, subtracted 1 from 2, got 1. Added 2 to 2. Subtracted 1, added 2, subtracted 1, added 2. Okay, so that's how we got our new QRST double prime. So Q double prime, R double prime, S double prime, T double prime right there. Then it says, is rectangle QRST congruent to rectangle Q double RST prime? Okay, so the answer to this is no, it is not congruent because the rectangle is dilated by a scale factor of 1/2. If it had only been translated, it would have been congruent. Okay, so here's our next one. It says plot the preimage of rectangle JKLM, and it has coordinates as follows. So J is -3, -2. That would be J is right there. K is -3, 2. Then we got L, and then we got M. Okay? And then it says graph the image of JKLM after a reflection over the x-axis. So reflection over the x-axis, if you recall, that means the y changes. So this is going to be x, -y. So that just means we're going to change the signs of all these y's, okay? So we did that. We got this -2 became a +2. That +2 became a -2, and so on. So now we have J, K, L, and M prime, right? Okay, so then it says dilate by a scale factor of 2. That means we're going to multiply everything by 2, right? So that's going to give us 2x, 2y. I'm going to go ahead and apply that rule. So we're multiplying 2 times -3, 2 times 2, 2 times -3, 2 times -2. See what these numbers are? 2 times -3 is -6, and so on, okay? And so when we plot those points, we get -6, 4. That was our J double prime, K double prime, L double prime, and M double prime. Okay. And then part 3 says, is rectangle JKLM congruent to rectangle JKLM double prime? And explain, no, it's not congruent again because the rectangle is dilated by a scale factor of 2. If it had only been reflected, it would have been congruent. Now I'm going to tell you guys that you need to make sure that you know all your rules for rotations as well. So let's go back over those. So if we have a 90-degree rotation, which would also be a 270-degree clockwise rotation, that means we're going this way, and that rule is what? -y, x, right? Then if we go 180, and that's both ways, that would be -x, -y. That's our rule. And then if we go 270 degrees or 90 degrees clockwise, that rule is y comma negative x. Okay, so you better know those as well as the reflection over the y-axis, which would be the sign of x changes. Okay. So this next one says in question, in the figure, L is parallel to M. So I'm going to go ahead and put some parallel marks here. That's what those are supposed to be. Let me try that again. Those are our parallel marks, okay? It says that the measure of angle, there was supposed to be an angle sign there. Y'all don't know what happened to that. The measure of angle 2 is equal to 43 degrees. So that's down there, which means this angle down here would be 43. And 3 and 1 would be, so to get 1, we do 180 minus 43. And that would give us 137, right? So this one's 137, which means 3 is 137 because they're vertical angles, okay? So 4 was 43 because it's equal to the measure of angle 2, right? So that's 43 degrees, okay? Then we're given angle 67. 67 is 11. So 11 is 67. So that means 9 would be 67 because it's equal to the measure of angle 11. So that's also 67. And we could do 10. 10 is going to be 180 minus 67 because they are a linear pair. They're right next to each other. So that makes this angle 113. And it doesn't ask us for 12, but this would be 113 and this would also be 113, either because of the linear pair relationship or because of the fact that they are vertical angles. 10 and 12 are vertical angles. Then we're given the measure of angle 15 is 110 degrees. So if 15 is 10, then 13 is 10, and those are vertical angles. And then we should know that 7 is 110 because it's a corresponding angle to angle 15. And 5 is also 110. We could say because it's an alternate exterior angle to 15, so it's equal to the measure of angle 15 because they're alternate exterior angles. So this one here is 110. And then 8 is a linear pair to 7. So we could do 180 minus 110. That's equal to 70, okay? So both 8, sorry, let's see if we can fix that. That was 67 over there, right? So let's do this one in red. This is going to be 60, what did we say, 70? This is 70, so that's 70, which means that's 14 is 70 and 16 is 70, okay? So this is equal to the measure of angle 8, right? Which was also 70 degrees, okay? And then 18. So if I'm looking at 18, it's the same as 9. It's equal to the measure of angle 9, which was 67. So that's 67 right there, which means that's 67. That would make this 113 and this 113. Again, corresponding angles. So you can say the measure of angle 19 was equal to the measure of angle 11, which was 67. And then the measure of angle 20 was equal to the measure of angle 12, which was your 113. And there they are again. angle ABC is bisected by BC, and if an angle is bisected by a ray, then we want to draw that angle first. So we're going to draw this angle here, A, B, D, and my problem was not written the same way else's, so I went ahead and fixed it. And then it's bisected, it says, by BC, okay? So if that's true, then we know that this angle is congruent with this angle down here, okay? Then it says ABC, which is the top angle, is 6x minus 9, which means the bottom angle is also 6x minus 9 because they're congruent. Then it says on y'all's paper that DBA is the whole angle is equal to 6x plus 18. So we have 6x minus 9 there twice, so we're just going to go 2 times 6x minus 9 and set that equal to our 6x plus 18. We're going to distribute that 2, so this is going to be 12x minus 18 equals 6x plus 18. I'm now going to subtract 6x from both sides. So now my 6x's are gone from there. I'm going to add 18 to both sides. So that negative 18 is gone. So now we have 6x equals 36. Divide both sides by 6. So x is equal to 6. Then we got to plug that back in. And then it's asking us for ABD. So we're going to plug it back into this formula. DBA and ABD are the same, right? So the measure of angle DBA is equal to 6 times 6 plus 18, that's 36 plus 18, which is 54. Now the way you can check this is to plug it back in here too. So 6 times 6 is 36 minus 9 would be 27, which means this is 27, and if you add 27 plus 27, guess what you get? 54, okay? All right, and there it is, all worked out again. The next one says, given that RT is perpendicular to SU, that means that there's also a right angle right there. It says SUR is congruent with RUV. SUR is this angle right here, and it says that it's congruent with RUV, which is right there. So we're going to put arcs on both of those. Then it says the angle R is 28 degrees. So what I want to do is I want to solve for this angle right here, okay? And to do that, we know that all three angles added together have to equal 180. So we're going to add 90 plus 28. That would be 118. And we're going to subtract that from 180, okay? And when we do that, we get 62 degrees, okay? So that means this angle is 62 degrees, which means this angle is 62 degrees. Now, hopefully you notice that there's a straight line right here. So let's go ahead and try to find this angle by adding those two angles together. 62 plus 62. That's going to be 124, and then we're going to subtract that from 180. And that's going to give us, what did I get? Let me see. 56. Okay, so now we know this angle is 56 degrees. Let me clean that up a little bit. So it looks like 56 degrees. So we can do the same thing on that triangle on the left to solve for angle T, right? So over here is that this is the angle we're looking for. So we're going to add 90 plus 56. That's going to give us 146. And we're going to subtract that from 180. And that gives us 34 degrees. That's our answer. So a lot of different things here that you're putting together. The Triangle Sum Theorem, the fact that angles added together equal in line have to be 180, and all that good stuff. So there's a full explanation of everything I did and why I did it. Okay? And that's also on the key. All right, then this next one says, what parts need to be congruent to prove the triangle congruent statement? So this is telling us that YXW is congruent with YJK by HL. So it means we've got a leg. We see the leg here, right here. This is a leg, and that's a leg, and they're congruent. But we need the hypotenuse, don't we? So that means the statement that we actually need here would be XW, and I'm looking at XW right there, is congruent with JK. So look at your statement if you're given it and use it to go ahead and pull your statement, your congruent statement, okay? Then on this next one, it's saying, what else do we need again? So we have a shared side, so we need that this third side is congruent, okay? So here again, I would use the statement. So I'm going to say RS, first two letters to first two letters, is congruent with DQ, okay? The next one's angle, angle, side, so we need another pair of angles. So this would mean this angle and this angle. Excuse me. So that's going to be angle G is congruent with angle V. Our next one is angle, side angle. So we have the vertical angles that are already congruent. We know that. Then we need another pair of angles, obviously. So we have a side between them there and a side between them there. So this is going to be the angle N is congruent with angle I. All right, the last one, we're looking for a side and then an angle, then a side. We have the shared side again. So we need to be careful with this one because it's going to be this angle up here is going to be congruent with this angle down here, the angle between the two sides, okay? So this time we can't name it with one letter because we have more than one angle there. So we're going to name it exactly the way it's written up there. Angle JKL is congruent with angle QLK. We have to recognize what we have. You should notice that FE is a mid-segment of triangle BCD. We'll say triangle BCD. And if I put a dot right there, then I could have all three mid-segments, right? And there's some things we know about these mid-segments. They're parallel, right, to the side that they look parallel with, right? And that they cut the sides in parts. So that means this part right here is congruent with half of that parallel side and half that parallel side. So if that's true, then it would take 2x plus 19s to get us the x plus 29. So that's exactly what we're going to do. 2 times x plus 19, that equals x plus 29. So that's going to be 2x plus 38 equals x plus 29. We're going to subtract x from both sides. So that's now gone. And then we're going to subtract 38 from both sides. So that's going to give us x equals -9. Then it says to find also FE and DE. So to find FE, we're going to go -9 plus 19, and that would be 10. And then to find DB, we are going to do -9 plus 29, and that would be 20. And that makes sense, right? Because DB should be twice FE. All right, so the relationship we're talking about in the next one is that the whole segment is, if we divide it by 3, we get the smaller part. And if we multiply that smaller part times 2, we get the bigger part, okay? So what do I mean by that? So let's just start with what we have. AG tells us that this AG right here is 10. So to get that bottom part down there, we would divide to get GD, we would take 10 and divide it by 2, so that's 5, right? And then to find the whole length, so that means this part down here is 5. Well, to find the whole length, AD, we would just add the 10 plus the 5, and that's 15, okay? We're going to keep doing these in different colors just to keep it clear. Now, FG, how does it relate to CG? Okay, so it takes 2 of FG to get GD, right? So that's exactly what we're going to do. We're going to go 2 times 2x plus 5, and that's going to be equal to our 3x plus 13. We're going to solve for our x, so this is going to be 4x plus 10 equals 3x plus 13. Subtract our 3x from both sides. So that's now gone from there, and this is x, and subtract 10 from both sides. So x equals 3. So now we're going to plug that back in to find FG, GC, and FC. So FG is equal to 2 times 3 plus 5. So that's 6 plus 5, so FG is equal to 11. So that means we expect GC to be 22. So CG, same thing. So we're going to go 3 times 3, which is 9, plus 13 is, yep, CG was equal to 22, which means the whole length is going to be what? FC is going to be equal to those two parts added together, 11 plus 22, so it's 33. Okay? Now for our final part, we are given that BE, the whole length here, is 18. So we're going to take BE, which is equal to 18, and we're going to divide that by 3, and that's going to give us our smaller part, so that's 6. So that means GE, which is our smaller part, is equal to 6, and then our BG would be equal to 6 times 2, and that's 12. Okay? Fundamental properties of a parallelogram with you first. So opposite sides are congruent, and diagonals bisect each other. So that's, these tick marks are telling me that that's what's happening here. So that's for our first part, LM and KM. And we're going to talk about JKL in just a minute. So for this, see that we have LM and KJ. So that means LM is equal to KJ. Thus, we're going to say 2x plus 5 equals 4x minus 15. Subtract 2x from both sides, that gives us 2x over here. Add 15 to both sides, that gives us 20. Divide both sides by 2, so x equals 10. So then we're going to plug that 10 in to find LM. So LM is equal to 2 times 10 plus 5, so that's 25. Then we're going to do the KO and the OM. Those are parts of a diagonal, and they bisect each other, so they're equal. So we're going to say KO equals OM. Same process, right? So we're going to do 3y minus 3 equals 2y plus 3. Subtract 2y from both sides, that gives me y. Add 3 to both sides, that gives me 6. So now what I'm going to do is I'm going to find KM, which would be the whole thing, right? So I could just to double check my work here, I could do 3 times 6 minus 3, that's 18 minus 3 is 15. And then we've got 2 times 6, that's 12 plus 3, that's also 15. And to get KM, we're going to do that 15 plus that 15, so that's going to be 30, okay? Now for our next part, it says find JKL. JKL is this angle up here, and KLM. Now we have a couple properties here that I want to talk to you about. Opposite angles are congruent. So that means these angles are congruent, but also when I add two angles that are next to each other, so if I add these two angles together, that has to equal 180. That means consecutive angles are supplementary, right? So it's asking us about JKL. JKL, that's that angle. And KLM. KLM. So these are two angles that are next to each other. Y'all see that? Angle L and angle K are next to each other. So we're going to add them together and set them equal. So we got 10A plus 15 plus 5A plus 15, and this is going to be set equal to 180. So 10A plus 5A is 15A. Obviously 15 plus 15 is 30. That equals 180. Subtract 30 from both sides. That gives me 15A. That equals 150. Divide both sides by 15. So A is equal to 10. So then it's asking us to find these angles. So the measure of angle JKL is going to be equal to 10 times 10 plus 15. That's going to be 115 degrees. Then we're going to find the measure of angle KLM, and that's going to be equal to 5 times 10, that's 50, plus 15, that's going to be equal to 65. And then you can check this again by adding these two together, And yep, they equal 180 when you add them together. All right, this last part B tells us that BE is parallel to CD. BE is parallel to CD. So that means we can use our fraction here, or we can cross multiply. We could use a ratio. So we could say little triangle over big triangle, because it says what triangle ABE is similar to triangle ACD by angle, right? So we could say 4 over this whole side, which is 12, is going to be equal to, let's just say x over x plus 10, right? That's one way to set it up. Cross multiply, that would give us 12x plus 4x plus, or equals 4x plus 40. That would then be 8x equals 40. Divide both sides by 8, so x equals 5, okay? So that's one way to set it up, or we can set it up as the fractions that you guys see, okay? Now the problem with that is it's not going to work with our base, okay? So we're going to have to go back to this here regardless. So, so we're going to do our 4 over 12 for the other side, and that's going to be equal to, can't even see that number, so that's 3, equals to 3 over our y. So here again we're cross multiplying, so we got 4y is equal to 36, so y is equal to 9, okay? So again, what I was talking about earlier is 4 over 8 is equal to 5 over 10, or x over 10, right? So you could do it that way as well for the other part, because the sides are parallel. But that's not going to help you with the 3 and the y. So on this next one, the first thing I'm going to do is go 12 minus 4. That's equal to 8. So that side right there is 8. So here we can cross multiply like we taught y'all, the quick and easy. Is 4 times x plus 6 equals 8 times 5. If you want to set this up in fraction form first, you can do that as well. And so that's going to be 4x plus 24 equals 40. Subtract 24 from both sides. 4x is going to be equal to 16. So x is equal to 4. Okay. Now over here we got to find a pair of sides that map to each other. So I notice that this side maps to this side. So I'm going to do my little triangle, 5 over 10.5. Then I'm going to set that equal to our p over our 27.3. Cross multiply again, so that's going to be 10.5p is equal to 5 times 27.3. So 10.5p is equal to 36.5. Divide both sides by 10.5, and p is equal to 13. Then we're going to do the other one, and we're going to use the same ratio again, okay? So we're going to use our 5 over our 10.5, and we're going to set that equal to now our 12 over our q. So here we go again, multiplying. So we're going to get 5q is equal to 10.5 times 12, and that was 126. So 5q equals 126. Divide both sides by 5, and q is equal to 25.2. All right, so here's our last section. It says use triangle LMN to solve for each missing side length. So we're going to use for this a squared plus b squared equals c squared, and hopefully all of y'all know that that's our c, because it's our hypotenuse, okay? So I'm going to just label this like it's given to us right here, and we're going to solve for LM. So we're going to go 21 squared plus LM squared equals 29 squared. So we get, I think that's 441. Yep, 441 equals plus LM squared equals 29 squared was 841. Subtract 441 from 841, LM squared is equal to 400. If I take the square root of both sides here, we can see that LM is going to be equal to 20, okay? So we're doing the same process for the next one. We're just going to go ahead and label it like we did the last one. LM, it says, is 10, and MN is 14. So really the same process we just did, right? So we could make this our A. So we're going to go LN squared equals 10, or sorry, not equals, plus 10 squared equals 14 squared, okay? So this is ln squared plus 100 equals 196. Subtract 100 from both sides, you get ln squared equals 96. So we're going to take square root of both sides here. It's going to get us to our ln. So that means ln is going to be equal to the square root of 96. And it says up there at the top to write our answers in simplest radical form. Okay, so that means we're going to divide this by, I'm pretty sure it's divisible by 3. So if we divide that by 3, we get 32, right? And 32 is divisible by 2, and that's 16. Oh, we'll check that out. We just got a perfect square. So what I'm going to do is I'm going to pull these two back together underneath the radical and put this underneath the radical as well. So that's going to be the square root of 16 times the square root of 6. And that would be 4 square root of 6. And that is our answer in simplest radical form. Okay? All right. Last two. A family is building a playground. The base of the slide is placed 8 feet from the playground structure. So we got 8 feet down here. To reach a height of 15 feet, there's our height. How long does the slide need to be? And obviously a slide we normally lean, right? So, yep, that black would be what we're looking for. So this is just a squared plus b squared equals c squared again, where this is a, this is b, and this is c, okay? So we're going to do 15 squared plus 8 squared, and that should be equal to our slide squared, right? So that's 225 plus 64 equals c squared. So that's pause. 89 equals c squared. So we're going to take square root of both sides. So c is equal to 17 feet. Okay. Then it says another family uses the same slide for part A. I don't know why I said ladder earlier when it's slide. Sorry, y'all. But needs to reach a height of 13 feet. Okay. So this time we're going 13, and we know that this is still 17. And it's asking us how far it needs to be set away. Okay, so that's what we're doing this time. So we're going to go 13 squared plus our x squared. That's going to equal to our 17 squared, right? Ooh. Okay, so that's going to be 169 plus x squared equals 289. So 289 minus 169 is going to be 120, so x squared is equal to 120, so we're going to take square root of both sides. So x is going to be equal to 10.95, so it says round, how far does the base need to put this? So let's just say it's basically 11 feet, y'all. Okay, because it's 10.95.